Hello everyone, today we're going to be talking about database security. For how big this topic actually is, we're not going to be able to cover everything in this video, so I encourage you to use Google to your advantage and to use this video as a springboard into the world of database security. This is a profession within itself, so it would be impossible to cover it within this video. So before we get into the intricacies of database security, let's try to define what that means. So the best definition that I could come up with was best practices you can and should follow to ensure your database is not compromised. A database for a company or application is its backbone. A company will use its database to make decisions. An application will refer to its database to give accurate outputs. If anything, an application is almost just a shell, and it refers to a database to actually give accurate and relevant information. So without that, it's a piece of code that, for example, can log a user in, but without a database, it won't actually be able to verify if that user actually exists or not. So that being said, let's jump right into the three concepts we're going to cover today. That's going to be access and user management, SQL injection attacks, and production data tables or databases. So first one is pretty self-explanatory. It's who is actually accessing our database, and once you have access to our database, what you're actually allowed to do. What do your permissions look like? Number two is SQL injection attacks. This is a pretty prevalent attack. I'm sure a lot of you have already heard about it, especially if you do any type of front-end coding or you've taken a database class or an SQL developer class. You should know what a SQL injection attack is, but we're just going to go over kind of what a SQL injection attack is and how your database can be compromised if you don't follow best practices by an end user. And finally, what does a production database look like? And how is that different from an analytics database? And what you should be doing in production databases to make sure that that data is secure. So let's go ahead and talk about user management. So this rounded rectangle is representative of how permissions work, right? You're going to have a root user that has permissions to pretty much everything in the database. They're able to read, write, but not only that, they're allowed to do things like create users, update passwords, override permissions. They are the super user, and they are the most guarded out of all users. The next two buckets we have are read and write permissions. Usually, it's common practice if you're giving something or a user a write permission, then you're also going to give them a read permission. But that's not necessarily the case. You can have programmatic users, and all they're allowed to do is just write to a table, and they're not allowed to query anything. It helps with compute times and compute optimizations, if you decouple those. So it just kind of makes more sense to have them decoupled, but usually it's common practice to just give read permissions to someone that can already write, because write is considered a more elevated privilege. So an easy way to visualize how a user might fall into this whole thing is, let's actually kind of try to draw one out here. So a user, let's say this is what a user kind of would look like. So obviously you're going to have the username, right? Let's just call this user one, if I can get it to work here. Nope. There we go, U1, right? So this is our user, this little guy here. And along with the user, you're going to store things like a password and let's just say it has a list of tables it can read from. So we're just going to call this the R list. And then a list of tables it can write from. So we're just going to call this the W list. So this is kind of what a user looks like, right? So I'm just going to group this together to kind of make it easier. So this is what a user looks like. And when you create a user, they're created, in here, in the database, and it doesn't have any permissions. So right now, if I were to have, all these, if I had a table, there we go. Let's say this is table T1, right? User 1 is created, but it won't even be able to read this table, so you can't even do a simple select statement on here. So you would actually have to update, as a root user or a user that has super user access. You want to go into the read and you want to say, hey, grant access to table 1 on user 1. So what that'll do is that will give this user a T1 permission. So it has added T1 to its read access. And so now this user can go ahead and query this table. Same thing with the write. You would just say, hey, grant write to T1. And as soon as that SQL statement is done executing, it'll add T1 here. So now this user U1 can read and write from this table T1. So that's kind of how it works. So how can we use this to our advantage in terms of database security? Well, if you have analysts, right, people who are primarily pulling data, you want to have a set user base that maybe populates the data. So those are maybe your, your software engineers who, populate the data through whatever app they have going on. And the analyst should only have read permissions to those tables that they're doing an analysis on, and maybe write permissions to one schema, a playground schema, where they can create tables, they can create views, but that is not affecting any of the production or like the analysis tables that they will actually be running analysis on. So that way you're kind of decoupling the two different functions, and you're kind of saying, hey, this user is only allowed to do these functions on this table. So let's talk about SQL injection attacks. So let's say you created this user called system_read. And this system user has the correct permissions where all it can do is read from this database, right? And so you've done your due diligence here, and you have this front-end application that allows for a user input, and it outputs the username, their date of birth, and their favorite food by scanning this database. On the back end, you have some type of SQL like select star from database, where user input is equal to user_input. And user_input reads from this function called input user, which is basically just taking in a string based on whatever they put into this front-end application. So this looks like a pretty good build, right? They're going to say user 1 as their user input. That's going to be set to user input. And your SQL will build saying select star from database where user is equal to user 1. And it'll output user 1, date of birth, and favorite food. Except it's not, because this type of build is prone to a SQL injection attack. So let's go to W3 Schools and see kind of what a SQL injection attack is. So we're going to go over a couple examples. So based on one-on-one is always true. So this line is super important, and I think this is probably the best way to put this is there's nothing actually preventing a user from entering the quote-unquote wrong input. The user can enter some smart input like this. So user ID, in the front end, when we're looking to get their input, they say 105 or 1 equals 1. So as you can see right here, this is the same query that we had, right? Built right here. Select star from database where user equals to whatever their input was. Well, over here, you can see that that's true, but then they've also added this extra junk, or 1 equals 1. And what that means is it says select star from the users where the user ID is 105 or 1 equals 1. And since 1 is always equal to 1, it's going to return all users from the user database. And this is something that you weren't intending. Another thing is this example. right, is what if they entered 105 colon drop table suppliers colon, like that, there, semicolon, I mean. So the SQL statement at the end would look like this. Select star from users where user ID equals to 105. Great. They're going to see what they need to see, but then they also just dropped your suppliers table completely from your database. Now, obviously, we want to stop this from even executing, but if you remember, we talked about user level permissions. So if this system underscore read actually had permissions to do that, it would go ahead and execute. But if this system level permission, this system user did not have permissions to do that, and only in this case has permissions to read, that drop table would have failed. So actually having the right user access the database is super, super important, because if this was just a system user that had, read write permissions and all the other permissions that go along with it, that drop table command would have also executed. So good thing that it was just a system read user, right? So how do we actually stop a SQL injection attack? Well, we use SQL parameters for protection, right? So to protect a website from SQL injection, you can use SQL parameters. The SQL parameters are values that are added to a SQL query at execution time in a controlled manner. So here we have the text ID equals request string user ID, and then SQL text is select star from users where user ID is equal to @0, and then when you execute it, you pass that in. So the parameters are represented in SQL with the @marker, and the SQL engine checks each parameter to ensure that it is correct for its column and are treated literally and not as part of the SQL to be executed. So you won't be able to pass in, whole SQL queries throughout. So I guess a common web language is ASP.NET. Text user is equal to get request string user ID. The SQL is pretty much the same thing, right? The customer ID. The command is equal to a new SQL command of the SQL. Command.parameters add with value. This is going to be replaced with the text user, and then we're going to execute. So these extra lines of code right here, having a parameter and adding that parameter in replace of that, actually protect your database from a lot of these attacks that we just went over. All right, guys, so let's say you've done your due diligence with your user level permissions, you've written the correct SQL with parameters to stop SQL injection attacks. How do you actually secure the data that's being stored in a database? So let's talk about production level databases or data tables. So what I mean by production is this data table or this database is supporting a production level app. So let's say this app is a login screen where you have to enter your username and your password. And that will go and pass that SQL back into the database and see if that user exists, number one. And number two is does that password actually correspond with that user? If so, let you log into the website, let's say. So even though you've done your due diligence with the user level permissions here, you've done your due diligence with the actual SQL that's being executed in terms of looking for SQL injection attacks, you never really know what's possible, right? At one point, SQL injection attacks were the biggest thing out there, and people had to work to figure out how to stop it. So there might be a different attack that you just haven't thought about. So let's say this is what your database looks like. You have a username and a password for that username. And let's say this hacker is smarter than you thought he was, and actually was able to get their hands on your database, right? So this is what they see. User 1 and their password, user 2 and their password. So basically, they've just breached your entire database by figuring out a way to get access to it. But what if you didn't actually store the username and the password, but instead you stored a salted and hashed value of it? So what is a hash? A hash is a one-way function that it only takes an input and throws out an output. So it's not like encryption where it's masking the text. It's actually changing the text into something. So instead of seeing user 1, if we hash user 1, and these are, different types of hashing. So there's SHA-256, SHA-512. This is what actually would be stored in the database. So this would be stored for the username. So basically, instead of storing this raw variable user1, you're going to take their input user1 and you're going to run it through a hashing algorithm. And then that hashing algorithm, you're going to check against the hashed version in your database. If they match, then they inputted user1. Because, there's no randomness to it. If I put in user2 and hit hash, this hash for SHA-12 is always going to be the same, right? So this is just hashing. Well, on top of this, you can also salt the hash, so you can actually add something to user1. So they pass in user1, and you add some salt to it, right? And the salt is just some extra concatenation that you add to the end of their username or their password. And you salt that, and you hash that. So you would be hashing, let's say, user1 plus salt. It could literally just be this. And you hash this. The original text was user1 plus salt. And this is the SHA-512 hash of it. So first of all, it's really, really hard to go from this back to user1 plus salt. But even if you do figure out a way, you're getting the user1 plus salt. And obviously the user1 plus salt would be a little better than plus salt. So it would be hard for the hacker to actually decipher what the username was and what the salt is. So by adding some hashing and salting, and using this in your production database and storing these values and hashing and salting their usernames and passwords, even if someone did get access to this database, they would just be looking at a bunch of gibberish rather than plain text of users and passwords. Awesome. So we've gone over these three concepts, and let's review them really quickly. So an access user management is managing permissions of a user so they can only do what they're intended to do on that database. A SQL injection attack is where a end user inputs wrong, quote unquote, wrong input, but it's actually a SQL query that can go into the database and create changes or output data that is not intended. We saw, that SQL injection attacks can be prevented through parameters, but also if you have the right user tied to that query, then you're able to also mitigate some SQL injection attacks just by permission denials. Finally, in production databases, we talked about how you don't ever really want to store raw data in a production database. If your app is hitting it to do any type of validation to see if that user exists, to check credit card numbers, to check passwords, you always want to hash and salt the input and store the hash and salted version, and always run the same hash and salt on their incoming input to check if that's actually accurate, rather than storing raw data. Because if for any reason a hacker is able to get to your database, then they're seeing a bunch of gibberish rather than plain text. So that's been it for database security. Please let me know if you have any questions. This is my first video, so I definitely am looking to improve. So I'm looking forward to any feedback in the comments below, and thank you for watching.